Okay, so you got an inclined plane question on the board. Okay, see what we remember from last week. I will tell you that there's one trick in that question, and it is the 340 Newton box. What are they giving you there? They're giving you the weight, right, the force of gravity. Okay, keep that in mind, that is not the mass. You can use it to find the mass, but it is not the mass. All right, so you guys can give that one a try here. Okay, so with all inclined planes, okay, we want to draw the diagram. With any question, we want to draw the diagram. So here's my inclined plane. Okay, it has a 30-degree incline. The box being set on top of it has a weight of 340 newtons. Okay, the other two forces in that triangle are normal force, which I won't need here, and F parallel, which I will need, and I have to remember that that angle there is the same as the angle of incline. Okay, so it is moving at a constant velocity of 1.5 meters per second. What does that tell me? There's no acceleration. If there's no acceleration, there's also no net force. Okay, so that means F net equals 0 newtons. That means that forces down the ramp and forces up the ramp are equal. All right, now I need to identify the forces. Obviously, one of them is F parallel because that force is always there, okay, in an inclined plane. It's the vector sum of these two forces. Right? Can I calculate it? I can, because I know the hypotenuse and I'm looking for the opposite side. Right? So if I want to get F parallel, I'm going to go sine of 30 times 340, which is going to be 170 newtons, I believe. Newtons. Okay. The applied force up the ramp is 200 newtons. Okay, since it's being pushed up the ramp, it's actually moving up the ramp. Which way is friction acting? Down the ramp. Okay, so this would be friction here. And I've drawn it small because how many newtons is it? The net force is 0. So the forces up the ramp and the forces down the ramp are equal. So, what do I need to get 200 newtons down the ramp? 30. Okay, I got 200 newtons up the ramp, I got 170 newtons down with F parallel. That means the force of friction is 30 newtons. That's it. That's all there is to that one. Okay, really, I did M times A, 0 newtons, and then I went F net equals F parallel plus the force of friction plus the applied force. Okay, and then I said, okay, I'm going to solve for the force of friction, so I went F net minus force applied minus force parallel equals force of friction, which was 0 minus 200 minus negative 170, which leaves me with 30 newtons down the ramp. Negative 30 is what it comes out to mathematically. Okay. Does everyone follow me there? All right. How many marks is a question like that out of? Yeah, 3, 4, maybe. Because really, how much did you have to do here? I had to draw a diagram. I had to calculate my F parallel, that would be a mark, and I had to do sum of all forces, that would be a mark, and I guess my final answer would be the 4th mark. Okay. Once again, not a lot of math, but a lot of understanding, okay, if it goes into a question like that. Okay. Is that ringing a bell from last week with the inclined planes? A little bit? Okay. Is this triangle always the same? It is. Okay. F parallel is always the opposite side. Force of gravity is always the hypotenuse. Normal force is always the adjacent side. The angle is always the same as the angle of incline. Okay, always, always, always. Okay, try that one. Inclined plane question, okay, and we have the mass this time. We're given force of friction. Okay. Take a little time on that and see how we do. Okay, so for this one here, we have a child sliding down a 25-degree hill on a sled, so it's an inclined plane. So 25 degrees. Child's mass is 50 kilograms. Okay. Since they're sliding down the hill, friction is acting up the hill, and it is 150 newtons. Okay, what's this force? That's gravity. Okay, calculate that by going m times g, which is going to be 490.5 newtons. Mass times gravity, 50 times 9.81. Okay, this force here is normal force, which I won't need for this question. This one here is F parallel, which I will need, and that angle is 25 degrees. Okay, so if I am looking for F parallel, okay, I need to solve for it using trigonometry. Sine of 25 times the hypotenuse, which is 490.5. Okay, so sine of 25 times 490.5. Okay, so 207.29 newtons. Okay, so far, does what I've done fit with the context of the question? The question said the kid is sliding down the hill. Did the two forces I've identified on the hill say that that should be happening? They do. Okay, the friction acting up the hill is less than the friction acting down the hill. Okay, so I want to calculate their acceleration. What do I do next? Find the net force. Okay, how do I do that?
The vector sum.
Vector sum of all forces. Okay, I don't have M and A yet, so okay, that's why I've got to do this. Vector sum of all forces, so that'll be F parallel plus the force of friction. Okay, I don't need to include gravity, and I don't need to include normal force at this point because I have already accounted for them by calculating F parallel. Okay? And if you recall, when I first taught you inclined planes, I said that's a very common mistake, okay? Is that people end up putting in gravity and normal force into the sum of all forces. They are already there. F parallel is already their vector sum. Okay, so we're shortcutting, that's the vector sum of those two. Okay, I want to find the F net. Okay, so F net will be 207.29 plus negative 150. Up the ramp is going to be negative here. All right, so that number minus 150, okay, gives me 57.29 newtons. I can't believe I just put that in the calculator. Okay, 57.29 newtons down the ramp. Now what do I do? Divide by mass. Now I use F equals M times A. So F net equals M times A. So A equals F net divided by M. Right? And that'll be our 57.29 divided by 50 kilograms. All right, so we get we only have two significant digits here. 1.1 meters per second squared. Downhill. Is this a very exciting hill? It is not. But it's a little kid. You don't want them to get too excited or go too fast because they're little. Take it from someone who had kids and put them down the hill. That was too fast.
The kid's like 50 kilograms, though.
Yeah. Okay. Still a kid. I went down the hill once with both kids on my back on the sled head first. It was fun until we got to the bottom and we ran out of hill. It was less fun. But no one got hurt. It was still fun. Okay, does that one make sense? Did I do anything different than any of the other Newton's second law problems that we've done? I mean, in the end, it broke down into those two steps again, didn't it? Sum of all forces and m times a. How you get to that is different every time, but those two steps are always going to be there. Okay? All right. Okay, I would like you guys to do the following. In your digital workbook, okay, you have on page 3 and page 4, you've got some vector problems. Whoop, too far. And you've got some vector problems, and you've got some Newton's second law with an inclined plane problems. So what I would like you to do is this. Oh my gosh, it's going all over the place. Okay, I would like you to alternate between the inclined planes worksheet, which is on page 3 and 4, with the forces of vector quantity worksheet. Okay, so do one inclined plane, then do one from the vector sheet. One from the inclined plane sheet, one from the vector sheet. 2, 3, 3. Okay, just alternate back and forth because there's going to be a few that we're going to run into that we're going to need to work on together. Right? For right now, I'd like you to start with the simplest ones. Okay, that would be like, let's say do 1 through 5 on each sheet for right now. Okay, then I'll pick and choose a few that I really want you to do. But for now, just to get refreshed and get our feet back under us. Okay, 1 through 5 from the inclined planes, 1 through 5 from the vector quantity sheet. I will circulate. If you're having trouble, let me know. Okay, guys, I want to look at number 4. I've had a number of people ask me about number 4. I'm walking around seeing a bunch of people stuck on number 4. Okay, so let's have a look at number 4 from the inclined planes worksheet. This is a very convoluted question. Okay, there's not a lot of like really tricky math in it, but it's convoluted, and it's that way because it's trying to see whether you can understand what forces can get you something different than just acceleration. Okay, so in this problem, we have a car being pushed up a hill. All right, so we know the hill is only 9 degrees. Okay, and we know that the car's mass is, well, we're looking for that actually. Okay, we're looking for the car's mass. Okay, our internal triangle always looks the same, and I should always draw it, even if I'm not given any of the forces that are in it. I should draw it anyway. Okay, so those are the forces that are in there. Now, what are the key words in this question? Constant velocity. What does that mean about the net force? It's 0. That means the forces up the ramp and the forces down the ramp are equal. Now, they outright tell me that the force up the ramp is 800 newtons. It's an applied force of the people pushing. Okay? They also tell me that friction is opposing, which means friction is acting down with 100 newtons. What's the other force that is always present on an inclined plane and acts down the ramp? That force. It's on every ramp because it is the vector sum of gravity and normal force, so it is always there. Since there's 800 newtons up and my F net is 0 newtons, how big is that parallel? 700. And most people have that on their sheets, walking around and seeing most people seeing that. Okay? Now, if that is F parallel, that means I know this side of the triangle. And I probably think, so what, there, it wants mass. Can any side of that triangle help me get mass? Which one? FG. Okay, because FG is M times G. And I always know what G is. It's 9.81. So if I can calculate FG, which I can use this formula to get the mass. It's convoluted, for sure. Okay, but it tests whether you understand that this triangle can work backwards too. We've never used it the other way. Okay, so if F parallel equals the sine of theta times FG, F parallel divided by the sine of theta should give me the weight, the force of gravity. So all I have to do is take my 700 newtons and divide by the sine of 9 degrees. Okay, so I get 4,474 newtons for my force of gravity. So what do I divide by to get mass? 9.81. 456 kilograms. Okay. Did we still do sum of all forces? It was 0. Did we still do m times a? We did, it was 0. Right? Say constant velocity. As soon as we see constant velocity, we've done m times a. Okay? All right. I'll give you guys a bit more time, especially to get into the vector ones, because there's a few in there that I'd like to go over, even though we only have about 10 minutes left. Okay. I'd definitely like to go over the question, I think it's number 3, about the fish. No, 4 is the fish. Try number 4. If you're not on number 4 on the vector quantity one, do number 4 right now. I'd like to be able to go over that one before class ends. Okay, so the fishing line is at an angle of 45 degrees from the water, so not happy. Okay, so the line goes like this. Okay, it is 45 degrees out of the water. Okay, friction is opposing. It says the fish is moving horizontally. That means that friction acts straight backwards with 80 newtons worth of force. Okay, we know we're looking for the tension in the line. Everybody with me on that? What are the key words in this question? What's the net force in this question? Okay, so how much of the tension in this line is straight forwards? 80. If the fish is moving horizontally, then it's not moving vertically at all. That means that that part of the tension in the line is 80 newtons because it's moving straight forwards at a constant velocity. Can I now figure out what the tension in the line is? Well, I got the horizontal component, okay, and I'm looking for the hypotenuse. Okay, it's just a trig question. Okay, I have the adjacent side. I'm looking for the hypotenuse. Okay, so the hypotenuse will be 80 newtons divided by the cos of 45, or the sine of 45, because it's 45, and it won't make the lick of difference which one you use in that case. Okay, 80 over the cos of 45 should give you 113 newtons, 45 degrees from the horizontal. You wouldn't even need the 45 degrees because that's for the tension in the line, which is actually both ways.
Is the 2 kilograms, is that extraneous?
It is completely extraneous because you never use it in this question. Okay? It is a measured value, but you don't use it. Okay? So you still have 3 significant digits though, because the 45 is used, the 80.0 is used. Right? The 0.85 is never used, it's irrelevant, so it doesn't affect. Okay? All right, you will have a quiz tomorrow on Newton's second law. We'll post at 3:20, same as always, have a look at it. We will be doing our lab on Newton's second law on Wednesday. Okay, so we'll have the tracks and the carts and the pulleys and all that fun stuff up for that day. All right?